Sorry, I don't
A big
speak
applause,
Spanish.
please, for the...
Thank you. So yeah, sorry, I don't speak Spanish, so I will talk in English, but please just remember that we are in the same boat. English is not my native language, so sorry if you don't understand me. First, I'd like to thank you organizers, because I know that you've worked hard on on inviting me here, so thank you very much. You can probably applaud the organizer. But there is a but, because I have two problems with the organizers. First, they forced me to wear this shirt, this flashy shirt, so boo for that. And they lied to me. They told me that the Barcelona weather was great. Actually, it's shitty. So, boo. So, thank you for being here. So we're gonna talk about crafting custom Android views. So, first of all, who's an Android developer here? Okay, great. So I'm not going to have to explain everything in detail. So who am I? So maybe you know me if you were waiting for me. So my name is Cyril Mautier. I'm basically an Android fan, and that's why I'm here. So you can find me on Twitter, of course, at Cyril Mautier, on Google+, or on my personal blog, which is cyrilmautier.com. And as an Android fan, I've been rewarded recently by Google as a Google developer expert. So I have to put a disclaimer here. Even though there is the Google name in my status, I'm not working for Google. So everything I will say in this talk is not approved by Google. It's just me talking about Android. So this is what I do on my personal time, but professionally speaking, I'm working for a company that you probably don't know here in Spain, because we're more focused on France and Germany, which is called Captain Train. And we are basically trying to revolutionize the way people buy tickets, train tickets, and travel by train. And if you're looking for jobs, we have lots of opportunities that you can find on this website. So let's start with how to craft Android custom views on Android. But in order to understand why we want to create custom views, we have to understand first what a view is. So let's start with an introduction to Android views. Let's say that I ask you a definition of a view. What would be the definition for it? Sorry, for you? Do you have a definition for view? Actually, no. A view it's actually funny, because a view is very important in Android development, but nobody knows a great definition of it. Actually, if you go to the Android documentation, and especially the view page, you will have this definition, which is that a view is a basic building block for user interface components. So basically, this is the atom of a UI. And if you go further in the documentation, you will find lots of views bundled in the Android SDK. Here are some names, for instance, the text view that you probably know, view group, view, linear layout. So a bunch of views like this are already bundled in the SDK. But how are they architectured? Well, we have to understand that first. So basically, a view is a class that extends object. So it's a simple view, a simple Java class, and below that you can find lots of other views, which are actually view does kind of nothing when you use it alone. Actually, what you use is some views that extends views, what I call personally simple views, because they only extend view. So for instance, an image view displays an image, and a text view displays a text. Yeah, thank you. So it's quite simple, isn't it? Text view displays the text. Well, actually, if you go to the source code of text view, you'll see that this is not that simple. It's probably something like 9,000 lines of code just to display text on Android. And below that, you can find some views that extends other simple views. A great example of that is the button. Button is actually extended text view because it has the exact same features that a view. It displays a text, and that's it. And there is a funny part, actually, on button. Do you know what is the difference between a button and a text view? Sorry? The background, yeah, the style, and there is another thing. Yeah, it's clickable. This is the only difference, actually, and that's quite funny, because if you're going to the source code of button, you'll see that it's quite simple. It's only maybe 20 lines of code, because it only extends text view, and that's it. Because all of the rest, all of the features are actually implemented by text view and view. The clickable behavior is implemented by view, and it's enabled at the button level. So basically, what does that mean? That button is just an alias. It's quite useless. If you want to create your own button, you could use a text view and make it clickable, and use a different style to make it more buttonish. So this is the funny part on this. So those are the simple views. But on the other side, you have some views that contains other views. And those views are called view groups. And if you remember your software architecture classes, do you know this design pattern? The composite design pattern. So this is basically a view that extends, composed view class, sorry, that extends another class and contains this class. So this is why you have this container. And the composite design pattern is great because it basically prevents third-party clients to add other views to something that is not a view group. So basically, you can't add another text view to a text view because text view is not capable of containing other views. Only classes extending view groups will be able to contain other views. And below the view group, you can find some well-known classes such as linear layout, frame layout, and this is quite obvious actually because they're all named layouts and they extend view group. Yeah, I know. I don't know why they decided to have different names between the class that is extended and the child classes. Actually, I think this is a mistake they've made prior releasing Android 1.0. But anyway, the view group should be called layout, and a linear layout and frame layout are correctly named. And all of that is forming what I call the view architecture. And when you look at that, you can see that view, the view class, and obviously the view group class, has been designed by definition to be extended. It is made for you to extend it. So if you're using all of these classes and looking at their source code in Android, you will see that they all use public methods, so you can do exactly the same on your side. If you don't want to use the Android views, Android SDK views, you can do that on your own. So what are the purposes of views, actually? Well, for me, there is three main purposes. The first one is measuring. So basically, and we'll come to that later, but basically what Android does is when you have to measure everything, it goes through the hierarchy and asks all views to measure itself. A view is responsible for layouting, so to be at the correct position on screen, and also, obviously, to draw something on screen. So those are the three main purposes. But a view is more difficult, more complicated than that. It's responsible for a bunch of other things, and that's probably why the View API is so verbose. It contains lots and lots of methods. Personally, I think this is the view the class in the Android SDK that contains the most APIs, besides activity maybe. And so in those responsibilities, here are some examples. A view is responsible for saving the UI state. We'll come to that later. For managing the drawable state, for handling touch event, focus events, over events, and stuff like that. So a lot of things are actually managed at the view level. So now that we understand what a view is, why do we want to create a custom view, actually? Because Android SDK contains a lot of views already. Well, I've spent a lot of time thinking about that, and I came up with four main purposes. The first one is to factorize. We are all great developers, so we are lazy. And we don't want to do the same thing over and over again. So by creating custom view, you can basically extract a behavior or a feature and reuse it inside your project at different places. And you can even reuse it inside your projects with an S if you're extracting it in a library project, for instance. The second purpose is to optimize things. As you know, on Android, the less, actually it's not related to Android, but to computer science, the less, the better. So the less you do, the better it will be. So by creating custom views, you can basically flatten the view hierarchy, so you prevent the system from measuring and layouting and drawing a bunch of views, and you reduce that to a single component, ideally, so that you can speed up your UI rendering and make everything smooth. The third purpose is to create something which is unique and groundbreaking. So that sounds like Apple. I'm not selling an iPhone here. I'm just talking about Android. But basically, what does that mean? It means that by creating your custom components, custom views, you will have an application that is not like the others. You will create something which is unique on the Play Store, and believe me, it's not easy to be unique on the Play Store when you know that there is thousands and thousands of apps on the Play Store. So for me, this is one of the main purposes of creating custom views. And finally, creating custom view can be quite useful when you want to access some views protected behaviors. What I mean by protected behaviors is basically protected methods at the view level. So for instance, if you want to know if a scroll view has scrolled, you have to extend scroll view because you need to listen to the on-scroll change event, which is protected. And there are lots of events like that. For instance, the visibility has changed, window attachment, scroll indicator position, and stuff like that. So now, let's start with an example. And in order to do that, I've created a demo which is basically an underlined text view. So I guess that you know, you basically want to create list view that are like the one that is in settings or in contacts, for instance. And in these views, in this application, you can find a section header. So for instance, when you are in the contact application, each contacts are sorted by their name. For instance, you have the A section, the B section, C section. And the A section is actually just a native view, which is a text, A, which is underlined. By default, you can't underline a text view on using the Android, the bundle Android views. So how would you do that? How would you do a view that contains a text view, and which is underlined? Sorry? Yeah, you can use Panable, but actually it won't go through from one edge to the other. It will only, underline the text. And for instance, if you go to the contact application, it goes from one edge to the other, so it's going through. But Panable is a great thing. Yeah, this is what we will do there. But I would have expected you to say we can use a linear layout with a text view and a view below just to draw, the underline. Actually, you can do that, of course, but you will use three views just to draw a text with an underline, which is quite. It's okay, but it's a shame because you can do better. And you can do that, as Fernando said, by extended text view, because basically what you want to do is to draw a text, but you want to make it, underlined. Another option would be also to use a 9-patch drawable as a background, but this has one major issue, which is when your designer wants to change everything. And if he or she wants to change everything, you will have to go through Photoshop and change the color of the underline, which is kind of difficult. Not difficult, but boring. So what we're going to do is simply create an underline text view. So here is the code. So do you see everything? So basically, this is a very simple project. So I'm using Android Studio, but I won't go into the details because David has previously explained everything about it. So what I'm creating here is underlying text view, which extends, of course, text view, because what I want to do is to draw text. And in this underlying text view, I will create two fields. The first one is a paint object. The paint object will be useful to draw the underline. And the underline height is actually the height of this underline. When you're creating a custom views, always try to create the three constructors. Actually, all of these constructors are very important. The first one is only when you want to create a view in the code. The second one is used when you are inflating the view via XML. And the third one is also when you are inflating the view via XML, but applying a theme. So by creating the three constructors, you'll be able to use the view everywhere. Because, for instance, let's say that you forget to create this constructor that only calls super, you won't be able to inflate it via XML. So that's quite a shame. And in this, oops, sorry, can you read? Yeah, it's okay. And in this view, I basically do one thing. In the draw method, if the underline is greater to 0, of course, so if there is something to draw, which is if the underline is greater to 0 or the underline is not transparent, then I draw on the canvas, the underline. So here I've used a trick, actually, which is using the padding, because I don't want to go through the measure path and the layout path. So instead of doing that, I'm just adding the underline height to the padding. So this is quite kind of a trick, but this prevents you from creating everything. So overriding on measure and stuff like that. And in this underline text view, I obviously have two setters, which is set underline text height, which sets the height, and set underline color. In this method, what I will do is I'll just check that the values are valid. So an underline height cannot be negative. And then when the values are different, then I can keep the value and obviously set the padding, because as I said, this is the trick that I'm using. For the color, this is exactly different. If the color is different, then I use the color. And I want to redraw, because if you're changing the color, it probably means that it means that the view is not in the correct state. The color is wrong, so you have to ask the system to redraw everything. And this is done with invalidate. And how do I use this view in my code? Well, this is quite simple. In my activity, I have on create. I create an underline text view. I set the text, the underline height, underline color, and I set the content view. So let's start this. Normally it should work. So I'm going to start Genymotion. So I don't know if you know Genymotion. I've wrote a blog post about it. Basically, it's like an emulator, but it's a fast emulator. This is a big difference. So now we're up and running. So let's start this. Local path doesn't exist. Come on. Maybe you can do that. Okay. I don't remember, yeah. So yeah, when you're using Gradle, you don't have to type everything. You can just type the first letter, and normally everything should be okay. So I don't remember the name of this, custom views. Yeah, that's it. So we have a text view which is underlined by this color, the blue color. So this is great, but actually we still have problems. And the problem is where this code is kind of messy. It's better to put the style and layout in XML, because it completely separates the logic from the rendering. So we will make this possible just by check out. I don't remember underline takes you to. So we use XML for view inflation. And in order to do that, this is quite simple. You go to your layout directory, and in this folder you will simply use the complete name of your view. So I'm in the com.cyrilmoutier.android.custom views package, .widget.underline text view, and this is the name, actually, the complete name of the custom view, and I'm adding it an ID so that I can get it in my code. It's match parent on the with, it's wrap parent on the head, and the text is here. So if I go back to main activity, the code is way simpler because I just have to set content view with this XML resource. And finally, I can get it through a call to find view by ID and set the properties like this. So UTV set underline height and set underline color. If I run that via command line, because it doesn't want it, I don't know what's this. Local path doesn't exist. Yeah. Yeah, it's okay, and it's working again. So the code is cleaner. It separates the logic from the rendering. So it's better, but we can do better because there is still something that is related to style, which is here. Basically, what we are doing is to set the underline height to the underline text view by code. We can do that via XML. But in order to do that, we have to create some stylable resources. So let's look at the code. So first, you have to create a file called attrs.xml. And in this file, you will have a declare stylable section. By convention, it has the name of your view. And in this declare stylable, you can have lots of tags, attr tags. So they have a format and a name. So the name is obviously the name that you will use in XML, and the format is the type of values that you want to attribute to this attribute and to set to this attribute. So the height is dimension, and the color is obviously a color. So now that we have that, we can go back to the view, and the code has not changed a lot, except that in the init method, I've retrieved the typed array. So basically what I do is context.obtain style attributes with the stylable resource. And thanks to that, I get a typed array. And in this typed array, I have all of the values that have been defined in my XML. So I can get the color, and I can get the height of the underline. And I set it via a call to set underline color. And this makes my main activity way cleaner, because I just have to set content view, and that's it. So let's look at the layout, because there is one trick here. The layout contains those attributes, additional attributes. So in order to do that, in order to make the serial namespace available, you have to add this line. So basically, you're telling Gradle and the build system that you're creating a new namespace called Cyril, and this namespace must have this name, because this namespace will be actually replaced at compilation time, especially the raise auto with your package name. So this is very important, especially if you're using flavors and Gradle, basically, because using flavors in Gradle, you can change the package name. So if you hard code the package name here, you will have problems, obviously, because the package name won't be in accordance with the package name of the application. So just by using raise auto, everything is fine, and that's it. So let's go back to the slides. Now that we know how to create a simple view, we can go back to the slides. Sorry. Yeah. So we've created what I call a simple view, because basically we're using the text view and just adding some behaviors to the text view. But we can create what I call some completely custom views. What do I mean by completely custom? Well, completely custom means that you extend view or you extend view group. And this is completely custom because view and view group they are designed to be extended, not to draw something or to render something. So by doing that, you have everything to do. And in order to do that, we have to understand, so to come back to what I said earlier, is to understand how Android renders the view hierarchy. So Android does 3 passes to render a view hierarchy. Those 3 passes are first the measure pass, secondly the layout pass, and finally the draw pass. The first 2 passes can be requested via a call to request layout. So when you're changing something in your view that may change the size or the positioning of the view, you have to call request layout. And if you're only changing, I don't know, a color or something that not change the position but only the appearance, then you have to call invalidate. This is why when I'm changing the color in my underline text view, I'm only calling invalidate. And when I'm changing the height of the underline, I'm calling request layout and invalidate because it may has completely changed. So what does request layout do? So let's take this example, this very simple example. We have a view hierarchy with a frame layout, which contains an image view and a linear layout, which also contains a text view and a text view, 2 text views. So let's say that the text view on the right, on the bottom right, wants to change itself, to relayout itself. So what it will do is it will call request layout. And request layout will say to the parent, hey, I want to relayout me. So please relayout me. And the linear layout will ask the parent, and we'll finally go to the root of the view hierarchy. And this is where the measure pass begins. So frame layout will ask the linear layout, hey guy, what's your size? But the linear layout doesn't know its size if it doesn't know the size of its children. So it will ask the text view to measure itself based on the constraints of the linear layout, of course. And once it is done, the text view is flagged as measured. Secondly, it will ask the text view to measure itself, which will be the exact same process. And now that we have the 2 text views measured, the linear layout can measure itself. So it will flag itself as measured. The frame layout will ask the other children it has, which is the image view. So the image view will measure itself and mark itself as measured. And finally, we can measure the frame layout because we know the size of all of the children. So now that we have everything measured on screen, we can lay out everything. So we'll go through the second pass, which is the layout pass. The layout pass is done that way. Now that we know where a frame layout, what's the size of a frame layout, we can, lay out it on screen. So it will lay out itself and then ask all of its children to lay out itself. So it will ask to the linear layout, which will ask to the text view, and finally, the image view will be laid out. And now that everything is correctly on screen, positioned on screen, we can go through the final pass, which is the draw pass. So the draw pass is done the exact same way as the layout pass. So the topmost, or it depends where what's your point of view, but the topmost views are drawn first, so the one that are far from you. So the frame layout is drawn, the linear layout is drawn, and then the text view, and then the other text view, and finally the image view. So thanks to that, everything is drawn on screen at the correct position. So now that we understand how Android renders, we have to, by creating a custom view, you have to inform the system what you want to do, what will be your measurement, your height, your width, where you will be positioned, and stuff like that. So in order to do that, we have to use first the onMeasure method. So onMeasure is called by the system when a parent view wants to measure yourself. So this is kind of a tricky method for two reasons. First, it has no return type. It's void because actually it has a contract, which is you have to call set measure dimension at the end of the onMeasure method. I don't know if you know why, because this is not really Java object way of implementing things. Actually, they've decided to do that because returning width and height would involve returning an object, and creating object means allocation, and allocation means you probably have the garbage collector, which will kick in the future. So in order to prevent that, they are only requesting you to set your measurement via the set measure dimension. And this is the exact same thing with the parameters, because actually we have two parameters that contains actually 4 values, because when you see, for instance, the width measure spec is not just a width, it's actually a constraint from the parent and a size. So this is kind of tricky, but actually if you read the code, it's quite simple to understand. So now that we know how, as a view, we can inform the system what is our size, we can obviously go through the second pass. The second pass is the layout pass, and you will be called in the onLayout method, which has 5 parameters that this time are quite simple. The first one indicates that you've moved on screen, and the 4 last one are actually the size of your bounds. So left is the coordinate relative to your parent, top is relative to your parent too, and right and bottom. So this is how you lay out things. And obviously there is the onDraw method, but I've not included it in this talk because I think everybody knows the onDraw method and we've seen it on the previous demo. So now let's talk about something that is quite difficult, quite different, which is saving and restoring a state. So basically, when Android, when there is a configuration change, which basically means you're, for instance, rotating from portrait to landscape orientation, Android by default will completely destroy the activity and the views on screen and recreate everything on the other orientation. And by doing that, it will obviously maybe lose some state. For instance, let's say that you have a progress bar, you have started to move it. When you rotate, you don't want to lose the state of, the amount of progress that you've chosen. And this is done at, actually, this save and restore behavior is actually done at the view level. So how can you do that? Well, this can be done quite easily. First, you have to create an inner static class, which has to extend base save state. This is a class that is available in the Android SDK, and it's basically a parcelable. So I don't know if you know what a parcelable is in Android development. It's like a serializable, but it's way efficient, more efficient. And as a parcelable, it has 2 methods. Well, the first one is describe. I don't remember exactly the name, but you don't care about it because you don't have to override it. The important one is write to parcel. So write to parcel will be called when you have to save your state. And what you will do in this, for instance, in the case of a progress view, you will simply save the progress, the current progress. So you will write, which is here an int, because the progress is saved as an int in my example. You will write it to the out parcel. And you have to, obviously, this is the documentation from parcel, so you have to create a field which is named creator, because the system will use it to create your parcelable. Once you have that, you can basically save the, so you basically have a wrapper of your of your state, but then you have to save it and restore it. And this is done with 2 methods. The first one is on save instant state. And in this method, this is quite simple. You have to call through the parents, of course, because you want the parent to save its state. You create the save state, which will be the wrapper of your state. You set the progress, you set the progress on the third line, and finally you return that object. So this is the object that will be saved by the system and restored and given to you after that in on-restore instance state. So when we are called by the system in on-restore instance state, this is where we want to restore everything. So what we will do is quite simple. Here we will ask the parent to restore itself with the super state, and obviously we will restore ourselves using the state saved in the saved state object. So this is quite simple, and this is something that you can do in your custom views very easily, just by overriding those two methods and creating an object that extends based save state. When you're creating custom views, you have to make it natural, make it real. And what I mean by that is you have to make sure that it fits to the user mental model. So what does I mean is basically when you're holding that and moving it around, you expect it to move it with your finger because you are acting on it. So basically it's to every action there is a reaction. And in order to do that, you can use the onTouch event method. So onTouch event is called by the system when the user is pressing or touching the screen or your views more specifically. And it can be called with different types of parameters. It will always be an event, but this event can contain lots of things. First, it can contain motion event.action down. So the event will be action down the first time you touch the view. This is probably because gesture has been started. So this is where you will initialize everything. Then you will be called through the action move. So this is where the user is moving on screen. This is where you want to move the object around so that they can, feel real to the user. And at the end, when the user is, stopping to touch the screen, you will be called with the action up motion event type, action type. And this is where you have to stop everything. You're not interacting with the object, so you don't have to move the object around. And finally, you can be called with a very special action type, which is action cancel. So basically, it's when a parent view wants to intercept your touch. So in order to understand that, here's the method that you have to use, but it's quite difficult, so that's why I've labeled it for experts only. But let's take a very simple example. Let's say that you have a scroll view with a button in it. When you are touching the button in this scroll view, the button will highlight itself so that you can touch it and click it. But if you start dragging or scrolling up or down, you will see that the button stops highlighting and the scroll view starts to scroll. And this is exactly how we have actually intercepted the touch event, which was targeted to the button by the scroll view. So with this method, you can do exactly the same behavior that the scroll view is doing to catch the event from the button inside of it. So now that we have moved everything around, there is something that is very important, which is to move everything until it reaches a state of rest. Let's say, for instance, I won't do that, but let's say that I'm throwing this smartphone over you. What would you expect it to do? Do you expect it to stop here just because I'm not touching it anymore, or do you want it to, to move in the air and reach a state of rest? Obviously, you want it to move slowly with friction and velocity going down. So we can do that, of course, on Android, and this is exactly what the list view does. For instance, when you are, scrolling very fastly and stop touching the list view will continue scrolling until it reaches a state of rest. So in order to do that, we have to do two things. The first thing is to track the velocity, and finally, you have to scroll your object to a state of rest. So how can we track the velocity? Well, Android provides you with a simple object, which is the velocity tracker. So in onTouch event, you will use a velocity tracker. If it's null, you create it, or you obtain it, because actually it's a pullable object. You add the movement, so you add the event, and velocity tracker will take care of everything. So it will start to compute the velocity of your finger on screen in pixels per second. And once you stop the gesture, which is motion event.action up, you will use this velocity tracker to compute the current velocity. So the 1000 magic number is in the documentation. It basically means that you want pixel per second values. And if this velocity is greater than a threshold, then you can start animating this object to a state of rest. And please do not forget to recycle the velocity tracker, because as I said, it's a pullable object, so you have to recycle it so that all of you can use it. So now that we have the velocity, we need to move everything around and to a state of rest. And this is done using an object which is called scroller or overscroller, which is available in the Android.view package. So you instantiate it, and when you want to animate things, just call through the fling method. If you want to fling, if you just want to scroll, then you can use the scroll method. And in this method, you have actually lots of parameters, but the first one is where you are, your actual position, the mvx and mvy, or the velocity on x and y, and finally you have the bounds, so the minimum values and the maximum values available to fling for the fling gesture. Once you've done that, you can start looping over and over again to check the current state of the overscroller, so to know if you have to move again, if you have to continue the movement, or if you've reached the state of rest. And in order to do that, you can simply post an animation, this runnable. And this runnable, the one on top, consists on computing the scroll offset. If the scroll offset if this method returns true, that means that you have to continue to move the object. And if it returns false, that means that the object has reached a state of rest. So in this here on the highlighting code block, it returns true, so we have to get the current x and y and move the object according to this position. And obviously, we want to continue moving the object, so we have to repost ourselves on animation. And if it returns false, as I said, the animation is over, so you're finished. And finally, if you want to create a custom view, please make it consistent with the platform. Don't try to replicate some custom views that you've seen on other platforms. So in order to do that, you can see that the Android SDK provides a lot of methods to do that, and lots of objects, of course. The first one is the edge effect. So the edge effect is the effect that you have when you're trying to, to scroll a scrollable container outside of its bounds. So this is exactly the case on a web view, on a scroll view, list view. So this is basically, they are all basically using the edge effect object, which is available starting, I think, the API 14, but you can use the support library to have it available through all of the Android version. And in order to do that, you have to first override the draw method, because this is where you will draw everything. And in this draw method, of course, you call through the super.draw method, because you want your parent to draw itself. If the edge effect is not finished, then you can draw itself. So you have to move the canvas appropriately. You get the width of the edge effect, you set the size, and finally, you draw the edge effect. And here again, this method draw returns a Boolean. And this Boolean is true when you have to continue drawing the animation, and it returns false when the animation is over. So if it returns true, you have to post invalidate on animation so that you're called on the next frame to render the next frame. But this is only the drawing part. If you want the edge effect to render correctly, you have to give it some information about the gesture you're using. So you have to go through onAbsorb when you are actually throwing the list view, for instance, and it's reaching an end. So you will call onAbsorb with the velocity at the appropriate when it reaches the edge. OnPull is called when you're trying to go further with your finger on screen. And onRelease, of course, is when you're releasing the object. So this is edge effect. So whenever you're creating a scrolling container, a custom scrolling container, you can use edge effect so that your view look like the rest of the built-in Android views. Some other constants are actually also bundled in the view configuration class. And this class contains, so this is the documentation, the documentation in the Android SDK. It contains methods to standard constants used in the UI for timeouts, sizes, and distances. So, for instance, in your constructor, you can simply get a view configuration object, which requires a context because most of the dimensions here are scaled depending on the density of the screen. And then you can get some constants like the minimum fling velocity, which is basically below this threshold. You don't consider that this was a fling, but just a scroll. You can also get the get scale touch slope or the get friction and stuff like that. So everything is available publicly in the view configuration class. So when you are creating a custom view, do not hesitate to use the view configuration class because this will ensure that the behavior of your custom view is consistent with the platform. So that's pretty much it. This is the conclusion. So in order to conclude this talk, I'd like to sum up with four important slides. So custom views are the best way for creating custom UIs. As I said earlier, this is the best way for you to stand out of the other application out there. Custom views must fit to the platform appearance. Do not try to replicate something that you've seen on another platform. Make it, use the language style, the style language of the Android platform. Don't try to create something completely new that has nothing to do with Android. A custom view must match a mental model. So this is very important so that your user can know how to use it, your views, and make it intuitive. And actually, there was no 4, but 3 final slides. Sorry. And that's pretty much it. So thank you very much for listening to me. And if you have any question, I'll be here later. So thank you. Was my Spanish okay?
20 team.
Yep.
Hi.
Hi.
Yes. Well, 2 small things. Well, one small, other not as. The first one is small, is where you say that the name of the view group because not all inherency as layout. For example, adapter view, extend of view group. And it's not a layout; it's a different component. But okay, it's a stupid thing. and the other stuff is you are not talk about the draw, but for me it's important when I do I invalidate over a view. This is going to mark a flag that is.
Of course, as dirty actually.
But now is all 3 execute for draw, or is only to? Because he draw in a buffer, and it's only this view drawing a buffer, or it's all 3? Or?
Yeah, this has changed actually starting Android 3.0. When you call invalidate, actually it will only invalidate, so you will go through the onDraw method only if the view has called invalidate, because previously everything was run again. And this is not true, because actually, not a buffer actually, but what we call a display list is stored. And this is this display list that is redrawn on screen. So, for instance, let's say that we have a scroll view with a button. No. Let's say we have a list view with 2 buttons and a list view with 2 items. If one item is changed, it's not necessary to redraw the other item. So what the Android system will do is actually the view that has changed, so the one that has called invalidate will ask the parent to invalidate everything, but this parent will only redraw the item that has changed, and it will redraw, but not using the onDraw method, but using the displays, the other item.
And it's drawn over a buffer that is going to be managed by the OpenGL system, no? Or
no. Actually, everything is drawn at the end, of course, in a buffer, in a frame buffer, but each view state or drawing state is not kept as a buffer. It's not like a big bitmap. It's actually display list because, yeah.
Hi.
Oh, sorry.
No, don't worry. If I wanted to animate a view,
yep.
Where should I put my my async task, or wherever I want to invalidate every time I do some kind of I don't know. I want to draw a line from left to right.
Yep.
And I want to do it in 1 second. So
yep.
where should I do that?
So you're basically asking how to animate things on screen?
Excuse me, can you repeat?
You are asking me to how can we animate things on screen? So
no, but only that view.
So some content in the view.
Yeah.
Okay, so if you want to do that, you have to use what I've showed with the scroller and fling events. You have to use post on animation. So basically, this will be called at every frame. So this is where you want to redraw yourself. So when you start an animation, when you start an animation, you will ask to redraw yourself in the next frame. So you will draw yourself, and then you will post again this requirement. So you will post again, that you want to redraw yourself on the next frame, and over and over again until you.
But where do I get the refresh time?
Oh, you don't need to have prior. I think it was Jelly Bean MR1. You had to have a refresh date, which was not available. So it was like something like 16 milliseconds, because it was the refresh rate to get 60 frames per second. Yeah. But now you can use the, actually there are new methods in the SDK, which are post on animation, post invalidate on animation. All of that will be actually called at the appropriate time. So you just have to call through post invalidate on animation, and you will be called at the appropriate time in the onDraw method. Okay, so you don't have to, for instance, use a handler and post a runnable that will draw yourself 16 milliseconds later. No, you don't have to do that anymore. You can use the API introduced in Jelly Bean, which are also available in the support library, in the view utils or view utils class, view addition. I don't remember the exact name.
Okay, thank you.
You're welcome.
I have a question regarding, hello? Hi.
Yep.
I have a question regarding the performance. So actually, I've noticed that once doing a custom view, when I was trying to scale and rotate the bitmap, it could take quite a lot of time, right? And
of course.
I haven't seen any pattern that could help us in the Android framework to do it in the right way, like double buffering. So do you have any hint on that? Shall we do that in onDraw function? Is it in another thread or in the main thread? Yeah.
So you're saying basically that you're drawing on the canvas a scaled bitmap? Yeah, and
yes,
animating
exactly.
that?
Exactly. So well, depending on the state or time, I just want to do it in a correct place and in correct position. But my question is, like, how would it affect the frame rate? Should I do it in some other thread or
no? Because actually you can't. You mean rendering a frame for this, each size of the bitmaps? You mean?
Yes, exactly. Because
I don't think because you will have to draw in a thread a new bitmap. You will have to allocate a new bitmap with a given size and then draw itself after that on the UI thread. So this is not...
So you agree that this kind, for performance optimization, these things shall not be done in on draw function directly?
No. No, actually, if you want to scale a bitmap, the best way, but it depends how your custom view is created. If you are drawing everything manually, so at the Canva level, then this is kind of difficult because you can't do anything. But if you're using the animation framework, so if you're using, for instance, an image view and scaling it, then the scale will be done by the GPU. So it's way more performant than just doing it at the Canva level.
Okay, so the answer is the animation framework, right? Okay, thanks.
But if you just want to draw a scale bitmap, then the solution of creating a temporary scale bitmap is okay. But if you're doing it at every frame, this is not okay. Yeah. Yep.
Hi. Do you have problems with the graphical layout editor in Eclipse, or maybe you don't use it anymore? Or it's solved on Adventure Studio?
Personally, I don't use it. Actually, I write everything on XML textually. I mean, manually.
But you are aware about the issues with?
Yeah, of course, there are some problems, but basically, I just use the graphical rendering layout just to see if my layout is okay. But most of the time, I use an emulator or Genymotion to see the actual rendering. But I understand that when you are a beginner on Android, writing everything like if it was natural is quite difficult.
Okay, thanks.
So, yeah. Yep, there is a question here on the front.
Hi.
Hi.
I write a table view, but I don't know if Android have a helper to draw the scroll bars.
Scroll bars, yeah, of course.
It's any helper or some class to...
Of course, at the view level. Actually, view is responsible for managing... They don't, this is the name, scroll bars. I thought it was scroll indicators, but no. If you look at the view source code, you'll see that there is lots of methods. So let me show you. The first one is awaken. So you have lots of methods, but they have some complicated names. So if you're extending view, you will have to just override those methods and return the appropriate value. So awaken, awake, yeah. So this method is used when you want to trigger, to ask the system to draw. Oh, sorry, you don't see what. Yep. Yeah, I've not talked about that because there are lots of features that you can find in the view class, but I don't have enough time to talk about all of them. So basically what I was showing you is awaken scroll bars. So basically, when you want to ask the system to draw the scroll bars, you just call awaken scroll bars, and the system will render the scroll bars. But how can you... So first, you can enable the scroll bars horizontally and vertically, of course. And finally, there is some methods that are get vertical, extend, I think. Not always remember the name, the exact name of the methods. Scroll bar, yeah, this is, so the width, the position, and there is another one, which is the extend. No, it's not this one, sorry. Extend. Oh, sorry. I don't, yes, it's in the view class. I don't remember exactly. But maybe I can, find the method later and I will talk to you about this. But there is actually 3 methods. I don't remember the exact name. Scroll bars. Let me look at that, yeah. No, not this one. If you have any other question, feel free. Don't remember the exact name. Scroll bar, before delay, no. Get. I don't remember his name. Nope. Okay, I will try. Yeah, if you have other question. No other question? Okay. Thank you very much.
Thank you.
Thank you to you, Sabine.